Okay, I want you to forget everything you think you know about wealth, about resources, about what's possible. Because within our lifetime, we are going to be harvesting trillions of dollars in precious metals from asteroids. And no, this is not science fiction. This is a rapidly approaching reality that's going to redefine our entire economy, push human ingenuity to its absolute limits, and honestly, change life on Earth forever. To really get your head around the sheer scale of what we're talking about, just listen to this quote from astrophysicist Neil deGrasse Tyson. He absolutely nails it. We're not just talking about some minor new industry here. We are talking about a fundamental shift in where humanity gets its most valuable stuff. And believe me, that trillionaire comment isn't just a catchy soundbite. To put some numbers on it, a single, pretty small metallic asteroid, we're talking just 2 kilometers wide, is estimated to hold about $20 trillion worth of metals. That's iron, nickel, cobalt, and yeah, lots of platinum. I mean, that is more than the entire GDP of the United States, packed into one single rock floating out there in space. It's just mind-bending. So yeah, that mind-boggling value, that is exactly why the commercial space industry is projected to be worth almost $1.8 trillion by 2035. And asteroid mining, well, it's not just a piece of that pie, it's really seen as the most transformative, the most lucrative part of it. It's the engine that could seriously drive a whole new era of economic growth. But you might be asking, why? Why go through all the insane trouble of going to space for stuff we already have down here? Well, the answer to that lies in some really urgent problems we're facing right here at home. Problems that make this whole celestial solution not just a cool idea, but maybe a flat-out necessity. Let's be honest, the reality of mining on our own planet is pretty brutal. By its very nature, it's destructive. This is an industry that literally moves more Earth than any other human activity. And what's the result? You get these enormous piles of solid and toxic waste, polluted water, and just gigatons of carbon dioxide being pumped into our atmosphere every single year. And here's the kicker. It's not just an environmental crisis. We're facing a resource crisis, too. The very elements that are essential for our modern world, the stuff in your phone, in green tech like wind turbines, we're literally running out of them. Some experts call it peak metal, and for a lot of these critical resources, we are approaching it fast. So the why is pretty clear, right? The big question is how? How in the world do we actually do this? Well, this isn't magic. It's a monumental engineering challenge, for sure, but it's one that's being solved right now by brilliant people in both private companies and space agencies. So let's take a look at the actual plan. So what's the game plan? It really boils down to 4 main stages. First, you gotta find the right asteroid, the one with the good stuff. Then you have to actually get your gear all the way out there. After that, you've got the super tricky part, mining in basically zero gravity. And finally, the really cool part, processing all those raw materials right there in space. Now, that first step, prospecting, it's already happening. Scientists use a technique called telescopic spectroscopy. The easiest way to think about it is like this. You know how a prism splits sunlight into a rainbow? Well, this method analyzes the unique rainbow of light that reflects off an asteroid. Every element has its own light signature, kind of like a fingerprint. It lets us read an asteroid's chemical makeup from millions of miles away and pinpoint the ones that are loaded with water or platinum. And this is where the real genius starts to kick in. One of the most clever ideas for extraction actually uses the environment of space itself as a tool. It's called vacuum distillation. You take the crushed up asteroid rock, you heat it, and in the perfect vacuum of space, the lighter metals like nickel and iron literally just boil away, leaving the super dense, super valuable platinum metals behind. No crazy chemicals, no heavy machinery needed. It's brilliant. And this isn't some Wild West gold rush where people are just launching rockets at random rocks. There's a serious economic model behind all of this. Companies are analyzing everything, an asteroid's orbit, its spin, its exact composition, all to calculate a project's potential profit. They're making sure these incredibly expensive missions are actually going to be worth it before a single bolt is turned. Okay, so of course, none of this is easy. Not by a long shot. The challenges are just as massive as the potential rewards. So let's hit pause for a reality check and look at the huge hurdles we have to clear to make this revolution actually happen. The first and most obvious hurdle, the absolutely mind-boggling cost. I mean, right now, it costs about $1,500 just to get 1 kilogram. That's about the weight of a pineapple into low Earth orbit. Now, add on billions for R&D for robots that can work in zero-G with huge communication delays. All told, economists figure the price tag to get even a small robotic mining operation started could top $100 billion. Who's got that kind of cash? And then there's the law, or maybe the lack of it. You've got what people are calling a legal vacuum. See, the big Outer Space Treaty from 1967 says no nation can own a piece of space. It belongs to everyone, the common heritage of mankind. But then in 2015, the US passed its own law saying American companies absolutely have the right to own and sell whatever they pull out of an asteroid. So you've got a direct conflict, setting the stage for a crazy geopolitical resource race that nobody's quite figured out yet. But if we can get past those hurdles, and it's a big F, the ultimate payoff is so much bigger than just bringing a bunch of platinum back to Earth. We're talking about forging a completely new frontier for all of humanity. The real game changer, the idea that unlocks everything else, is a concept called In-Situ resource utilization. It's a fancy term, but ISRU basically just means living off the land, using the resources you find in space to do more stuff in space. This is where the future really starts to take shape. Imagine you mine water ice from an asteroid. You can split that water into hydrogen and oxygen. Boom, you've got the most powerful rocket fuel we know how to make, right there in space. You take the metals you mine and feed them into 3D printers to build spare parts, tools, even entire habitats. Suddenly, you don't have to launch every single thing from Earth anymore. This creates what they call a mass payback ratio. For every 1 kilogram you launch, you could generate over 100 kilograms of useful material in space. This is how you build a real, self-sustaining human civilization in the solar system. So, when you put it all together, what do you get? You get this incredible opportunity to create immense new wealth and literally build our future out in the cosmos, while at the same time, we get to solve one of Earth's biggest environmental problems. We'd be moving our most destructive industry off of our precious living planet and onto lifeless, dead rocks in space. It's a win-win on a scale that's hard to even comprehend. And that brings us to one final, really important thought. We are standing right on the edge of the biggest resource boom in the history of our species. The tech is coming, the money is starting to flow, and those asteroids are just waiting. So the question we have to ask ourselves is, what kind of future are we actually building? Is it a sustainable one that benefits everyone like the old space treaties dreamed of? Or is it just going to be the gold rushes of the past exported to the stars for whoever can pay the price of admission? The choices we're making right now are going to decide